Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating blog post about running ArchiveTeam's Warrior project within a Kubernetes cluster. It's a really cool application of containerization for a worthwhile cause.
Right, I'm eager to hear this. The blog post mentions using VMs initially, but then shifting to Kubernetes. What were the main motivations behind that switch?
Yeah, the author initially used a Proxmox VM, following a readily available guide. But that limited concurrency to 6 jobs per Warrior instance. This was a bottleneck, especially during the co-host archival effort. The move to Kubernetes offered scalability, allowing for more concurrent jobs.
Makes sense. So they found a Docker file on GitHub but had to adapt the Kubernetes manifests, right? What were the key modifications?
The original manifests used a static node port, assuming only one instance. The author made it more dynamic, using environment variables for configuration. Crucially, they added an in-memory empty-dir for data storage. This was essential because their Kubernetes nodes have relatively small disks, only around 16 gigabytes. Using memory avoids disk space issues and actually speeds things up.
So essentially, they traded disk I/O for memory usage. But wouldn't that lead to frequent ohm kills?
That was the initial thought, yes. They set a memory limit just above the empty dir size, so if the volume fills up, the pod gets OM killed, and Kubernetes replaces it. However, a later update revealed a surprising detail. Kubernetes doesn't actually clear the in-memory volume on OM kill. That's unexpected.
Wow, that's a significant finding. So the initial assumption about ohm kill behavior was incorrect. What other changes were made after this discovery?
The author discovered the grab container images, which are optimized for archiving and don't include a web UI logging to std out instead. This simplifies things considerably. They also integrated a Python script to monitor pod performance, pulling metrics from the Kubernetes API. It's a quick and dirty solution, but it works well for monitoring memory usage.
So a shift from a single, potentially overloaded Warrior instance to a scalable, Kubernetes-managed deployment with improved monitoring. And the discovery of the grab images further streamlined the process. It sounds like a really efficient solution.
Absolutely. The blog post also links to the author's Kubernetes manifests and the improved Python monitoring script. It's a great example of how Kubernetes can be used to efficiently manage resource-intensive tasks, especially for collaborative projects like ArchiveTeam's efforts. And it highlights the importance of iterative development and adapting to unexpected behavior.
Definitely. It's a testament to the power of open-source collaboration and the flexibility of Kubernetes. A great case study for anyone looking to deploy similar applications. Thanks for breaking this down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.